Hello, everyone. Welcome to Control Automation Day 2022. My name is David Peterson. I'm the Director of Engineering Content here at Control.com and your host for today's keynote. We're excited to bring you some of the best educational resources to help you succeed in a fast paced, always changing industrial environment. The topic of Control Automation Day this year is Programmable Logic Controls, or PLCs. Although most of us have some idea of what that looks like and feels like, the explosive growth of technology has and will continue to always provide new and exciting ways for us to use these devices to increase safety and efficiency of our operations. Nowhere is this more true than in the case of open source hardware and software. Usually, that's designed to move our devices and our inventions from concept to reality as quickly, efficiently, and best most cost effectively as possible. We are excited to welcome our friend and guest, Massimo Banzi, the co founder and CMO of Arduino. This name is well known to electrical engineers who've often used this platform in their own learning or their prototyping of their own inventions. I'm excited to meet with Massimo and learn about one of the recent announcements, which is the Professional or the Pro series of Arduino. One of the key features of this line of Arduino platforms is its durability and ruggedness, which is the demands of the modern industrial shop floor. So let's welcome Massimo to our keynote address today. Massimo, thank you so much for joining us here for Control Automation Day 2022. We're really excited to have you here.
Thank you very much for having me. It's an honor.
So I wanted to start with a little bit of a background introduction. I think many of our audience is familiar with Arduinos, the platform, the boards. But for those who aren't, can you give us just a little bit of the background story of how it all got started?
Yeah, absolutely. So, in a way, Arduino started in a bit of a strange way for an electronics tool. It started off as a way, as a tool to make it simpler for a bunch of master students in design to learn how to use electronics to create prototypes of the things that they were designing. So, it was essentially designed in a way that people with very little understanding of electronics and very little software experience could really build working things. And I guess one of the tricks that we use was to basically shift the responsibility to microcontrollers so that it was easier to explain to an audience of people that have no understanding of electronics. And it started off as that kind of tool, and then it sort of took a lot of different directions and touched a lot of different communities, but it started off as a tool for design students.
So can you identify a point at which you really recognize that Arduino was a huge international success?
Well, I think one of the interesting things that happened in the history of Arduino is that it started to move to different communities, and then musicians and artists, and then at some point it intersected this community they call makers, and that obviously that accelerated the understanding of Arduino in a lot of different sort of contexts, and a lot of people start to really build a lot of projects. Probably would say about 10 years ago is when things started to become really, really, it was really clear that Arduino was very successful. For example, I got invited to talk about Arduino at TED, the conference, and we started to organize big events with a lot of people. So it started to become also a tool that companies use to prototype ideas. So it kind of left the sort of experimental world of the design school where it started, and it started to become a tool that was used in a bunch of different schools and universities to teach the basics of microcontrollers, and then it started to become a tool for companies for prototyping.
So I just wanted to kind of go back to when you graduated college and were first getting started with electronics. What did PLC technology look like then? The industrial control system technology, and did you ever really see yourself getting involved with this where you are today?
Well, actually, it's interesting because industrial automation was always a passion of mine. It's kind of a, my uncle has still has a company with like a big factory. For me as a child, it was amazing to go and look at the factory operating. And when I was probably in the first year of high school, he bought this massive milling machine. It's like one of these massive machine with multiple heads, multiple tools, and multiple axes, and it was very, very fascinating for me. So I was always interested in that kind of stuff. And so when I was in high school, I studied in this high school where they teach technology. So we did software, we did hardware, and a lot of the controls at the time, the people used a lot of sort of Z80 based boards back then. So in fact, we studied quite a lot of that. I studied how to program in Z80 assembly language. I don't know. I think also because I'm originally from Italy, and Z80 was like super popular in Italy as a tool because it was manufactured by the company that's now is known as STM. It was used to be called SGS, so it was like very, very popular as the way. So yes, people had PLCs, but this kind of control computer based on Z80 were quite popular at the time. And in fact, my first computer was was running on a Z80 processor. But I would say, in the end, I then I started to do mostly software in my career. So I kind of left a little bit that world of electronics. I missed it quite a bit because I like to build things, but then I did more and more kind of software. So I had this urge to go back to electronics, and I did it later on when I started working on Arduino.
That probably is familiar with for a lot of people now who started as kind of that maker environment, that atmosphere of wanting to invent and create and design. Do you think that's still a growing trend and will continue to grow as we start seeing more? And I'll be in that category as well, having gotten started with Arduinos before getting into control systems. Do you think we'll see more of that transition from those kind of people into those industrial environments where they have to put some of those new skills and knowledge to test to invent new processes?
Yeah, absolutely. I think this is actually one of the main focuses of Arduino right now, to figure out how you can take the recipe of Arduino and apply it to industrial systems, building electronics that's designed to industrial standards, but keeping that kind of spirit of simplicity, of ease of use. Also, there's another interesting situation. Arduino has been around for quite a bit. So we now have a situation of people who learned Arduino maybe in junior high school or even earlier, who have maybe used Arduino also in college to build things. So now they graduated and they've been using Arduino for several years now. And I think that's one of the forces that's driving the interest that people have in Arduino in industrial context, because these people have been using Arduino all the time, and they know that if they pull out an Arduino, they can build something in half an hour. And a lot of the classic tools for certain tasks, they take longer and they're more complicated. So they like the fact that they can quickly build something with Arduino. And some of the tools that we are building now allows them to take what they built and make it into something very, very robust. So I think in a way is the arrival of the first Gen Z or late millennials into the workforce that is kind of pushing also the adoption of this kind of technologies.
Yeah, so that's interesting when you say push the adoption of technologies, because I was kind of wondering if the Arduino Pro series, which is really what we're kind of focusing today's discussion on, was that an initiative that Arduino as a company decided to start inventing and pushing more adoption into industry, or was this more of a reflection of seeing the Arduino already being adopted and then just configuring the boards and software to allow that change more easily?
Actually, yeah, it was a. Arduino started working on these products that we call Arduino Pro, as a reflection to the fact that people started to use Arduino in industrial contexts. And so sometimes we saw people actually building piece of equipment with like an Arduino Mega inside. No, actually, if you look at a lot of the 3D printers that people buy right now, they even have like an actual Arduino Mega inside, or they have an electronics that's evolved from the open source design of the Arduino Mega. So that is the first context where you saw a bunch of equipment that was powered by an Arduino. And then it started to become something that people in industrial automation started to use. And obviously we realized that, the old models of Arduino, they are consumer electronics. They are okay in certain very simple sort of not mission critical type application. So we started to figure out, okay, is there a way that we can build hardware and software and bits of cloud that can actually work in a real industrial environment? So we started to design products that are designed to industrial temperature range, that follow a bunch of the different regulations regarding certifications of things that you need when you install them in an actually industrial environment. Or even we do also products that go in smart agriculture, so they need to be in the middle of a field, so the or sensors that are used for smart cities, so they are placed outdoors. So I think it was a reflection of looking at people. There was a demand, but we wanted to respond with tools that were the right tools, not like a consumer product kind of hammer to become a control system.
Obviously there's a bunch of well-known applications of Arduinos for the IoT, the Internet of Things. We can measure weather, temperatures, whether a door is open, closed, that kind of stuff. We see tons of examples of those, but now there's this industrial Internet of Things, the IIoT. And so you mentioned some of the capabilities like the temperature withstanding, the humidity, the certifications. But what other kinds of application considerations were made in the context of the IoT? Or really, I guess what I'm trying to ask is what makes the industrial IoT different from our typical IoT application cases for an Arduino?
That's an interesting question, because what you call industrial IoT in Europe has this name called Industry 4.0. No? So there is this idea that y- the factory floor has to take a step forward, and the systems are all connected to each other. Every piece of equipment is exposing inner data in a way that can be exchanged with other equipment, and then you can send it to some cloud platform so you can monitor it. I would say a lot of the IoT projects that people did with Arduino up until now, there were things like people building I don't know, a weather station for their apartment, or doing home automation, or doing very little lightweight type automation, or we saw this company that were making a system to water a field for agriculture that was essentially derived from an Arduino Mega. But then we started to meet with people that had slightly more sophisticated use cases, and we realized the technology has to go. So we started to use, for example, this new class of processors from STM, which is called the STM32H7, which is a dual core microcontroller. We adopted a real time operating system. So you're still programming with the Arduino layer of the Arduino framework, but your code is running on top of a real time operating system that has all the tools so that you can make the code run reliably. Also, the products that we make for Pro, they all come with hardware crypto chips, so that you can store certificates in the device. So when you have communication with a cloud server, it's not you don't use like a simple username and password, but there is a certificate based authentication. So it's not something that's it becomes a lot more robust as a technology. Um, and then starting from the base building blocks from this kind of processor, we start to go in a lot of different directions. Just to give you an example, this thing is, we call it the Portenta machine control, effectively has, there is a powerful, oh, you have it on the wall. There's a powerful microcontroller in there, but there is a bunch of interfacing electronics on the PCB, which is the same kind of electronics you will find on a PLC. So very robust inputs and outputs, the ability to control different loads, input for encoders. For example, this particular piece of hardware is used by a company in Italy who makes industrial ovens. So they make, for baking pizzas or baking croissants, that kind of stuff. So they redesigned their machine. So this is both the control system for the machine, but it's also the IoT interface. They can remotely manage their ovens completely, do a lot of monitoring and interventions remotely. So there's a bunch of use cases where these tools now, an oven is a situation where it's hot all the time. So you need something that's designed to withstand the kind of um, heat and other conditions where you need something robust. But we designed this based also on the experience of working with this company. And I would say another area which is super important right now for us is okay, you have all this, we have a cloud that we designed that lets all these different bits and pieces talk to each other. But we also did quite a bit of work on machine learning. So, how do you run machine learning on simple devices? Well, simple in terms of they are complicated inside, but they are simple to this thing is a little sort of postage stamp, but it can run uh, different AI, what we call tiny machine learning algorithms internally. So you can do recognize shapes, recognize objects, you can recognize sounds. So in a way, the range of things you need to do in contemporary industrial projects, for example, following this industrial IoT or Industry 4.0 requires a completely new set of skills that might not be so easy to find on the market. And I think Arduino helps bring in a bunch of people to this particular market.
Yeah, certainly. I know that with PLC technology specifically, which is really what this whole control automation day is all about, I think there's people focus a lot on the hardware because obviously the hardware is very important for any system. But those capabilities that you're mentioning, the things like machine learning, artificial intelligence applications, I think are sometimes confusing for people to understand. It's things that happen in the background, not things that you can see and touch and feel. And I think control engineers and technicians just inherently, I can consider myself in there too. Hardware, giving that physical aspect is really important. And you mentioned there the things like encoder connections, but also I know that this one has the digital inputs and outputs, analog, and based on those that know about Arduinos, the typical voltage levels are 5 volts, analog inputs for 0 to 5. And traditionally, that's been a little bit difficult to connect industrial technology to because the voltage levels are a little bit different. So, was that also something in the design of this industrial series where it scaled up those voltages a little bit to consider sensors, push buttons, 24-volt systems, things like that?
Yeah, for example, this Portenta machine control is designed in a way that the IOs can work up to 24 volts. And actually, the IOs that you see on the terminals where you put your cables, they are galvanically separated from the microcontroller. So we use some interface chips that are used also in PLCs, so that the signal, the 24-volt signal, is galvanically separated from the very low voltage signals on the microcontroller. So the device is, quite robust. We also interface a bunch of different temperature sensors, because again, a lot of the tasks that we saw people doing were based on some kind of temperature control loops were included in the process. So in a way, we looked at ways where we could build something that would be very robust, that could withstand a lot of can we say abuse from the application that the people put them through. So in a way, it's a completely different kind of product. So it's not the classic Arduino. I think the value in a way is that you can, if you know how to use Arduino, you can bring your code and you can run it, and the system will let you run the code on a different infrastructure and a different hardware, but the principles that you learned you transport, no? And I think this is something that's quite important at the moment, at least from what we can see, for example, here in Europe, but I think the US is the same. There is a big difficulty in finding people who can actually work on this kind of projects. And the fact that you can figure out ways to make the technology more welcome drives more people to the field.
And when that technology is easily accessible to people who have that background, they're much more willing, and I think their workplaces would be more encouraged to allow them to invent and create better ways to do those processes. And I think that creativity is really what drives progress in industry.
Yeah, for example, with these particular tools like the Portenta machine control, what we try to do is to basically create a system where you have different paths. So you can be essentially a young person who learned how to use Arduino at some point, and you can bring your Arduino experience and write code and take advantage of all the Arduino code. But for example, if you have experience in PLC programming, we also made a partnership with a company that develops essentially an integrated development environment for PLCs that was ported on this board. So you can use ladder logic, and you can use all the other, I think, three different standard languages for PLCs on this thing. So the idea was, if you have an experience already, you can use that tool and you can program with that. You can come from Arduino, or if you want, you can even use Python. So this hardware supports MicroPython. So you can even bring Python if you want. So we try to figure out a way how to bring as many people as possible to this, because as I mentioned already a couple of times, we see that especially the small and medium companies that for me personally are very interesting to observe are having a hard time finding people with the skills. If you're trying to implement something in the industrial internet of things, you need to have someone who understands hardware that can build all the different systems. They need to understand software. They need to understand cloud protocols. They need to understand about security and how do you build a secure system. You might also need to understand about some machine learning, because there are some vision tasks there. Then you need to understand how to build a cloud service, and then you need to understand about Linux. So if you look at all the different building blocks that a modern industrial system that follows this industrial IoT industry 4.0 requires, the skills are so many. So what we are trying to do is to provide a ramp for the people who used how to learn how to use Arduino in the past, for example, to be able to build robust professional applications. And one of the things that I'm very interested in is also, I believe that by using something like Arduino, we can take people who are currently working in an industrial context and might not have the skills. We might be able to retrain a bunch of people, because Arduino has that ability to kind of be simple. It's got a simple, gentle, learning curve at the beginning that might help, bring more people, retrain people to understand these technologies.
Another thing helping that learning curve is just the fact that there's so much documentation and freely available learning for Arduinos, as opposed to many proprietary companies where there's learning available, but it usually comes at a great expense of time and cost to get trained in how to use that particular hardware and software.
Absolutely. In fact, I think one of the things that I really like about how the whole Arduino ecosystem evolved is the fact that now, if you want, you have multiple classes that you can take on Coursera or another, or Udemy or Skillshare, whatever website you can. There's a bunch of classes that we run. There is a lot of free documentation. You can find a ton of documentation. There's like thousands and thousands of videos on YouTube of people explaining, how to build things with Arduino. I was looking a few days ago for some videos explaining stepper motors and how to control stepper motors to show to someone, and I realized there's like a ton of videos of people taking apart stepper motors, explaining how to drive the stepper motors with all the building blocks of knowledge are just available with a click. You just need to, if you have an internet connection and some crappy laptop, you're done. You can learn. And I think this was one of the things that was also very important for us, is to put as much knowledge as possible out there so that people can learn with the least amount of friction.
And I want to keep talking about the software, but really quickly before we get away from hardware, I know that another concern for companies is not just the physical connections to the input and output devices themselves, but also communication and networking ability. And I know that the machine control board is designed with an Ethernet interface, but it also allows various other connections, things like HMIs, RS-485, and those other very common industrial networking from a hardware side. And obviously, with networking, you have to deal with both hardware and software capability. But it looks like it's designed both wired but also with wireless networking capabilities to be applicable in a lot of different situations.
Yeah, obviously, one of the things that we have been doing for quite a bit is connected tools. No? So as I mentioned, we have a cloud that now we are releasing for more industrial customers, but we have been building connected projects for a very long time. So we have been adding all sorts of connectivity to our products. So this Portenta machine control comes with all sorts they have Wi-Fi and Bluetooth, okay, but they are probably slightly less useful for certain industrial application, but wired Ethernet, CAN, RS-485, and there is a lot of libraries, some written by us, some written by the community, that allow you to connect to all the different protocol, Modbus, and all the different industrial buses based on RS-485 and CAN and Ethernet. So in a way, uh, interfacing with other systems, there are even libraries built for Arduino that allow you to communicate with a Siemens PLC or with other industrial equipment by established manufacturers. Also, because one of the things that I think when people talk about Arduino in the pro world, in the industrial world, they think that we are saying that you need to take and throw away everything you have and put Arduino. And effectively, we're not exactly saying that. If you have a system that works, that's great. We have a huge capability for interfacing. And one of the tasks that we see people having to face right now, a lot in the industry, is retrofitting. No, you have a system that works, but you need to extract data so that you can have it on a platform where you can analyze that data in multiple ways. So a lot of the things that we do with the Portenta machine control is sometimes just to be side by side with a conventional control system to extract information, to inject information, so that your control system keeps going, nobody touches it. But you can then adapt all the information and bring them out. And I think really big task. A lot of people are working on it. I was talking to these people from a large company in Europe, and they say they had 12 different factories built in different times in the last 30 years. So they have multiple different types of common, ways of controlling their equipment. So they were really looking for a tool that they could just when they could go into a factory and figure out how to interface specific machine from a specific vendor. So I think these some of the things that work very well with our tools is this kind of applications.
Yes, absolutely. I've been in many of those interoperability situations with many brands, many generations of the same brand, and they're all they're all working in harmony, but sometimes only barely. One small adjustment to the system, and nobody has the entire set of skills and knowledge to know how everything is playing together. So I think that's really important because most people would look at replacing their system as being an impossible challenge. There's no way they could replace it, and so something like a solution presented in that way would be impossible for them. So that ability to work alongside and give them other options to add a network. The idea of the libraries, though, is really interesting. Understanding how libraries work from a traditional Arduino perspective. So with these ones, does that mean that if somebody has for example, a variable frequency drive, there would be support for them in adding that extra peripheral equipment to that Portenta control system in a way that feels more like an easy to use interface coming from the company itself, the OEM?
Yeah, it's the ecosystem of Arduino libraries is quite spectacular because now we have more than 4,000 of them. They cover all sorts of different problems. Clearly, just to put a disclaimer, like every open source software, some of them are amazing, some of them are really great, some of them are probably written by someone who had to kind of quickly hack together something. So every time you adopt some software written by some person on the internet, you always have to kind of keep an eye and check and test it. But it doesn't mean that that software, since it's open source, it has more bugs than a commercial software. The advantage you have is that you can actually look inside, and if there is a problem, you can actually try to fix it. If there is a feature that's missing, you can actually try to intervene on it. No, and but this we have libraries that cover interfacing with a lot of different types of equipment, and we've seen that that part is something that's quite makes a lot of people happy because they can figure out a solution for an interfacing sort of a problem quite quickly usually, because a lot of the work has been done by other people who had the same problem before you and fixed it and decided to release the code. Sometimes we build the code, so some of the libraries are built by us. And also, we have now a group of people internally to the company that sometimes help customers when they have a very specific interfacing need or they need a specific piece of code. We can do it. And we are now building a network of system integrators who are trained to use the Arduino technology. So if you are somewhere in Ohio, probably there is a system integrator who is working with us directly. They can actually come in and build a system or find a solution, who has access to the development team. So I think these are the ways that we're trying to help people. If you want a completely hands-off process, you just go online, take the files, and build it. Or if you want to get more involved and you want more help, there are ways you can get more help.
So that discussion that you mentioned earlier about the ladder logic programming, I think that's an important point to discuss just a little bit more, if it's still in development stage, because I think that's really important for people who have that background in PLCs and the background in more of the electrical and mechanical world. And so understanding how the libraries work in more of the traditional text-based language, is that a similar approach to how the plan is to have it work with these IEC 61131 compliant, which I assume is the baseline for how this integrated development environment is working? Is that library support also intended to be available to those with the who choose the ladder logic programming path, those easy to integrate options?
So the tool that we chose is built by a company that's been building this kind of development environments for 20 years. And they also supply a number of PLC slash industrial automation suppliers in Europe. And so they have quite a lot of experience. And so they ported their compilers and everything to the Arduino platform. There is a certain degree of compatibility between the Arduino libraries and these languages. So they expose some of the functionality. And for example, we have exposed some of the Arduino cloud functionality. So, for example, if you're using this cloud service to manage your application, to send data to within this PLC development environment, you can actually, in a way, you have an object that's kind of the Arduino cloud or an MQTT server or some other type of connection, and you can send the data to that. So in a way, it is it's not like just doing the ladder programming or just using the IEC languages. It's actually adding all these different functionality that are more, more close to the way we build things with connect with cloud and connections and so in a way it is a bridge towards the Arduino kind of way of building things.
And so some of those users would still naturally expect to have access to things like an Ethernet message or a maybe a PID process control loop, those things that are critical for their operations and they're used to seeing. But the functionality in the background gives them, in some cases, it sounds like a lot more power to customize an approach in ways that they may not have had with a more proprietary OEM software.
Yeah, no, it's a very flexible environment, and I think I don't know what's interesting is the fact that you have so many options. So depending on what you're trying to do, you can pick one tool or the other. So we wanted to give people a bunch of options. We didn't want people to say you program this with Arduino or you program this only with ladder or another language. So we wanted to give, depending on what you're trying to build, this is a system where you have some kind of a runtime that gets ported to the hardware, and then the runtime has internally all the different in a way facilities that you need to have a robust piece of software running a control system, for example, because you have all the different watchdogs and other features that make the whole code very robust. And this type of runtime is something that this company has been developing for 20 years. So it's not something that we hacked together last month. It's based on something that's been running on a bunch of different uh, equip type of equipment for 20 years.
So I know there's another category of controllers that kind of exists between the machine control connecting directly to all of the IO devices and field devices, and then the far other end is cloud processing where everything happens completely remotely. But there's also this area of edge computing, which brings the processing ability closer to the equipment. So there's less data transmission, therefore less latency time, more real time response for safety situations. Is that another application of the capability of this processor? Is those edge control situations?
Yes, absolutely. So one of the things that we have been most interested in the last few years is this development of this edge computing. A lot of the tasks, for example, I've been doing quite a bit of work on this thing they call tiny machine learning, tiny ML, and I think it's quite interesting how now something again the size of a postage stamp like this has enough computing power then it can do object recognition at 30 frames per second, and then has can send over a connection that information. I think that is super interesting for me for a number of reasons. First, because you run your algorithm locally, there's no cloud involved. So there is privacy. The images that you're taking never leave the device. They are processed locally. So if the cloud goes away, you can still operate. Also, you save on bandwidth, you save on power because this thing is a microcontroller at the end. It doesn't consume so much power, but there's so many places. For example, one of our customers was building this machine, which is essentially a production line for shampoo. So they had a sensor to detect the position of a bottle. Now that sensor has become something that can detect if the cap is mounted properly. But from a control system perspective, you still have this go no go type message, but the system is doing extra, and they program this thing basically the system they built is built using a Python development environment called OpenMV, and they run essentially a TensorFlow micro algorithm. So in a way, you can do some very, very interesting things. Or I was talking to some people the other day that are using this thing to build an insect trap. Because one of the big problem in agriculture is that sometimes when a certain kind of insect shows up, your crop is in danger. So these traps are basically just a sticky surface. The insect lands on it, and you need to take a picture and understand. And and this works really well for this kind of tasks. So this fact that you can do now these kind of tasks locally, it's quite interesting. And I would say one of the things also that we started working on is that we launched this new sort of processor, which is kind of a Linux capable board, still family, same Portenta family. It's called the Portenta X8. And so it's an IMX8 processor, so it's a quad core Linux machine. But one thing that I think was very interesting was the fact that we work with this company to build the software infrastructure where you have different containers. So when you want to deploy an application in the field next to where you're collecting the data, next to where you're processing, you just deploy the container remotely, and everything that your application needs in this little container, software container, and it just flies into the board and runs. And this makes it super easy to manage this kind of edge computing tasks where you have to distribute applications and you can move them closer or further away. And I think these are the kind of things that we think are very important for the way we are going to be building systems now.
A question that probably a lot of people have. I think this would be impossible to answer as one blanket statement. But what is the amount of time commitment that's required to get projects up and running out of the box? And I know that would depend on somebody's background and experience in using these interfaces. But is this machine controlled? Is it designed to be something that gets people up and running with projects as quickly as logically possible? Because time, especially downtime, is so expensive when it comes to equipment.
I thank you for this question because this is exactly one of the things I'm very passionate about. Because one of the things that we tried to solve when we started working on Arduino is this concept that in interaction design we call friction. The idea is that when you're trying to achieve something, you will face certain degree of friction. When we started working with Arduino, if you wanted a microcontroller, you had to call the distributor and maybe they will give it to you. So it was very complicated. No, a lot of the documentation was not easy to reach. A couple of years ago, I was trying to get a PLC from a famous manufacturer up and running. And the whole process was, I understand the way they work, but the problem is that, you had to register for their website and the software, you needed a special license for the software and they wouldn't really let you download. So it was a very complicated, the barrier to entry was incredibly high for something that's got a few inputs and outputs and 8 relays, you know. I was like, this is mind blowing. The amount of energy that I have to put in is so that I can change two settings into a thing that's got 8 relays inside. It's just insane. And so, one of the things that Arduino tries to build is something that when you get something and you pull it out of the box, in 15 minutes, you need to, from scratch, you need to be able to do something. So in the old Arduinos, we used to call this the time to blink. How much time it's going to take you from when you get the box and your computer doesn't have any software to the point you're blinking the LED. The
Perfect.
time to blink is a very important parameter for us, because we want you to get this thing out of the box, connect the cable, download the software, go to docs.arduino.cc, follow the getting started. The software is not behind any registration, paywall, whatever. It's all downloaded. It's everything is open source. Everything is documented a lot. There's also forums. There's a Discord channel. There's a bunch of different channels where people can help you. And if you're building a pro project, you can also get in touch with Arduino or the system integrators. But the general idea is that a person with minimum amount of knowledge following the tutorials in 15 minutes needs to be able to do something with this thing, you know. And
So getting it up and running initially is, I know that the speed of deployment, the speed to blink, that's kind of the foundational story of Arduino. But then also another concern, I guess, is the ongoing maintenance. So when something goes wrong, the ability to troubleshoot and solve the problems. Because I guess to think that you're going to install something and then never have to worry about it again is not realistic. But is that another feature of this platform, is the ability to use common multimeter tools to be able to troubleshoot the voltage levels, things like that on this board?
obviously, this type of equipment is designed in a way that it's easier to instrument, easier to sort of inspect, easier to debug. Also, there's also like quite a lot of degree of modularity. So in case something goes wrong with the main processor, you can just snap it out and plug in another board, and you're up and running. And I think that modularity is always another thing that Arduino always was very important for us. You know, that you can build something out of different kind of modules from a hardware and a software perspective. Obviously, the fact that we provide connectivity on each one of these things also allows you to build very quickly using the tools that we provide, systems that let you monitor everything you build remotely, which I think it's an important feature, no? Because if you can, for example, the people who build the famous industrial ovens, for them it was very important to be able to monitor the devices remotely, where while they were on the customer side, because they wanted to be able to debug and solve problems, diagnose problems remotely. Then, from a hardware perspective, clearly this hardware is different from a classic Arduino board. For example, all this equipment have got these connectors where, if you want, you can plug in these JTAG probes, and you can actually debug the code at the lowest level possible. So in a way, you know, you can go as low as you like on this thing. So it's designed so that it can be used also by a professional developer and not miss some of the features.
Yeah, I think that's very reassuring to those who like troubleshooting at the hardware and the software level. So I think finding those people who are easily able to solve problems in all different worlds equally is a difficult task. Those kind of people are very rare to find. Well, I know that there's a lot more information about the different boards and applications at arduino.cc. There's a link to the professional right up in the top left corner of the screen. So I'd welcome anybody to go and check out that link. There's a lot of application examples, a lot of documentation, and just a lot of other information available for those who are curious about what this board might be able to do for them. So with a couple of more minutes, we have some fun questions for you.
Okay.
So being Being an Arduino enthusiast myself, I have many different versions of the boards. And I know you're not supposed to pick a favorite child, but would you say that there are any boards in the history of Arduino that you would consider to be your absolute favorite of all time?
Obviously, there is. I am quite partial with the Arduino Uno because effectively it's the original format that we made, and it still sells, in the millions right now. If we just actually had, we made a special edition of the Arduino Uno because we officially sold 10 million of the official Arduino boards. Then also, you know that there's a lot of different vendors who make compatible boards. So the number of users are way more. But I think the Arduino Uno, in a way, it's kind of the one that get the whole thing started, and it's still incredibly popular, and it's still incredibly popular because it still solves problems well. So sometimes people they're like, but this does everything I need. I don't. Also, the boards in the MKR family are something that I kind of attach to because we were trying to solve the problem that you need to build sometimes you need to build these connected nodes, and you need battery chargers and security and connectivity and everything else in the standard format. And before, the boards were all that random shapes and connectivity, so we tried to create a family where you can write your code and you can move it to all sorts of different ways of connecting and getting data from the net. And we tried to put all the different things you needed to build an individual IoT node on the board. So I think that was something also that I'm kind of attached to.
Well, you mentioned that the special edition, the little miniature Uno, our EE Tech headquarters, the Control.com headquarters, had one of those sent by one of the vendors that we work with. And so I finally got to hold one myself. I've wanted to since it was released. Very exciting moment. So small.
Yeah, yeah, it's kind of one of our engineers worked on it, and we thought this is great. We need to make it. Why don't we make it as a special edition for this occasion? And
And with the black PCB and the gold printing, it looks so wonderful. So with the popularity of Arduino, you're definitely a well known name, a living legend in the world of electronics and electrical engineering. Do you think you're ever going to retire from this line of work, or is the Arduino family and the evolution of this product line, is this something that you're ever going to be able to get away from?
well, I think one of the interesting things about the Arduino, effectively, it's a formula. The Arduino formula is try to look for complex technologies and try to make them simple for a wide audience. So originally it was the microcontroller. Then we tried to make it simpler to do connectivity and to do IoT. And then we've also been interested in building tools that make it easier to teach kids about electronics. And then we're now working on tools who are making it easier for people to build industrial systems with Arduino. We're working on tiny machine learning. So I think there's always a new challenge that you can apply the formula to. And so I think there's probably still quite a lot of work that can be done. Then obviously, I'm a maker. I like to make stuff, so I always get fascinated by new things. And I don't think you can retire from being a maker. You know what I mean?
That's
You
true.
don't retire from that because that's not really a job. It's just the way I am. I like to build stuff all the time. So it's part of who I am and what I was when I was a child. So I will never retire from that.
Well, Massimo, thank you so much for joining us here to present this keynote for Control Automation Day. We really appreciate the time that you've spent. I appreciate it. This is fun for me, being such an enthusiast of the Arduino line, of you. This is just a really exciting chat, and thank you so much for the time that you've given us here today.
Oh, thank you very much. It's always a pleasure.
Our thanks to Massimo for his time today and for his contribution to many young engineers, including myself, who have been heavily influenced by the Arduino platform over the years. We encourage you to stay and check out all of the other exciting resources that we have on control.com, including this week the launching of many new ebooks, PLC tutorial videos, and news and technical articles presenting both theory as well as many new exciting product launches that were announced at some recent industry trade shows. Thank you also for your involvement in Control Automation Day, where just by registering, you're automatically entered to win one of the grand prize drawings for our events here today from our keynote addresses. We hope that you had fun and learned some new insights that will help you advance your own career in industrial control systems.